So, in digital signal processing, we learn about discrete time signals and discrete time systems. Actually, what is meant by a discrete time system? Or before going into the main digital signal processing, we should know what is a system is, what is a discrete time system is. A system can be defined as a device or an algorithm which transforms the given input signal x of n to y of n through some prescribed criteria that we call it as a system. So, a signal can be modified with a system to y of n. A system can be a filter, a system can be an amplifier. Any device or any algorithm which transforms the given input signal to y of n, we call it as a discrete time system. To be very specific, we can say that a discrete time system that processes or operates on discrete time signals to produce an output signal. A discrete time system is a mathematical or physical entity that transforms an input signal sequence x of n into output sequence y of n through some specific operation or rule. The transformation can be represented as y of n equal to transformation on x of n, where t defines the type of operation. So, to be very specific, we can define that in this way. Now, why these? Why we have to learn about the discrete time systems? In digital signal processing, we try to construct different types of systems, different types of filtering we do. And the algorithm which transforms that or which filters the signal, the entire algorithm, we can call it as a system. Or even a system can be a physical quantity also, physical circuit also, it can be a system means. Now, if you see the different classifications of the system, we have different classifications of the systems. So, one classification is that linear and non-linear system. Now, when we can say that a system is linear means if the system obeys superposition principle, then we say that the system is linear. If it doesn't obey the superposition principle, then we call it as a non-linear system. What is meant by superposition? When the sum of individual responses has to be equal to the sum of the response of the sum of the inputs. Okay, the sum of the individual responses has to be equal to the response of some of the inputs. Then we can say that a system is linear. It has to obey the rule of additive. It has to obey the rule of homogeneity. Then we can say that a system is linear. If not, if this principle is not obeyed by a system, then we call it as a non-linear system. And if you see the time invariant and variant systems, how we can define a time invariant system means if the input output relationship between the system does not change with the time, then we say that it is a time invariant system. If it changes with time, then we say that it is a time variant system. So the example is that sometimes we have a system which works better in at particular temperature, and if the temperature changes, the behavior of the system also changes. So at the daytime it may work in a different way, at nights when it is very cold it may work in a different way. So like this, a time invariant and variant systems can be defined. If the input output relationship does not change with time, then we call it as a time invariant system. If it changes, then it becomes a time variant system. And we have another classification which we call it as a causal and non-causal system. A causal system is a system where the response of the system depends on present and previous inputs. A causal system depends only on present and previous values. And any real-time system is a causal system. Any real-time system is a causal system. The response doesn't depend upon the other stored values, other future values it doesn't depend upon. Such a system is called as a causal. A non-causal system means if the response depends on future inputs, as y of n equal to x of n plus x of n plus 1, then we can say that a system is a non-causal system. A non-causal system exists in non-real time. It doesn't exist in real time. And what are future inputs means? Usually we don't have any future inputs. If the response depends on some stored values, if we design a system with some stored values, then it can become a non-causal system. So the difference is that it depends on the time. If the response depends only on present and previous values, it becomes a causal. Or if it doesn't obey this rule, it becomes a non-causal system. And similarly, we have another classification, stable and unstable system. What is stable system and what is unstable system? Now, stable system has to follow a property of Bibo. It means that bounded input and bounded output. When we give a finite value of input to the system, the output also has to be finite value. If the input for a bounded input, if you get an unbounded output, that means if you get an infinite value of the output, then we say that it is an unstable system. So stability relies on finite values of inputs and outputs. A finite value of input should produce a finite value of output, then only it becomes a stable, otherwise it becomes unstable. And similarly, we have a static and dynamic system. So what is meant by static? If the response of the system depends on only present inputs, then it becomes static. The response doesn't depend upon any of the previous values or any other values other than the present, then it becomes a static. A static system is a memoryless system because as it doesn't depend upon previous values, it doesn't require the memory. And if the system depends on any of the previous or future values, then we can call the system to be dynamic system. A dynamic system requires a memory. So easily we can identify static and dynamic. If y of n depends only on x of n, then it is a static. If y of n depends on some of the values of x of n minus 1, n minus 2, n minus 3, etc., or y of n minus 1, n minus 2, n minus 3, then it becomes a dynamic system. So thus we have classification of discrete time systems. Thank you.